So I wanted to talk a little bit about effects of land use on streams and also non-native species, and these sort of connect in a way. But I don't know. I read this article the other day and it kind of blew my mind. So I like to share articles that blow my mind. Pikas, right? Who knew that they're critical to stream ecology or hydrology in general? This is really interesting. So on the Tibetan Plateau, pikas are growing in population size, and so they're burrowing rodents, right? So they tunnel underground. And this area doesn't get a whole lot of water, but it turns out that they're real important in increasing like infiltration of water into the ground because of their burrows. But people don't like them. Their populations are increasing. Yeah, so like degradation of the landscape is increasing their population. So people started poisoning these pikas. This looks like a stuffed animal. Who would poison something so cute? And basically what they show is that poisoning of these pikas reduces infiltration rates of water across the whole plateau because they're not keeping their burrows active anymore, and that affects like the hydrology of the whole area. It's kind of interesting, you know? So the question is, are they a pest or are they a keystone species? So I thought that was kind of interesting. Last time, talking about dams. And this is embarrassing, but I've completely forgotten. What are some of the ways that dams affect stream ecosystems that we talk about? Yes. No, sorry, what? Barriers of migration, absolutely. Yep. What else? Yeah, right. Okay, yeah. Yeah, and that's right. And so in some ways, species diversity is kind of the variable that responds to the impacts too, right? So like the barrier to migration can lead to fewer species upstream. And then the idea of like fewer species upstream and downstream is a strong trend as well. And that's what's causing that in general. Like, so you can have the barrier to migration, which affects things. But then, yeah, so it's altering the habitat. Yeah, so right, it's turning a lotic into a lentic habitat, right? So deeper water, slower flowing behind the dam, sediment. Yeah, so localized habitat alteration. Yeah, so all these things, the migration barrier, altering the habitat, it's a haven for non-native species. And then we even talked about the way that that stream ecosystems work differently, right? That the particularly carbon is processed differently in reservoirs than in rivers, right? So it's getting turned into methane because it's in an anaerobic environment at the bottom of the lake, which is worse for climate change than if it's mineralized into CO2 by consumers in an aerobic environment. So yeah, talking about methyl mercury as well. So yeah, you know, dams can change our ecosystem in all different kinds of ways. And I think it's kind of, I don't know, interesting in a way when we think of like how humans affect ecosystems. Like, to what extent can like our understanding of the theory of ecosystems predict that? Like, to what extent can we say, all right, built a dam here, we'd expect the ecosystem to change this way because of this? So in some ways, when we look at human impacts in ecosystems, it's really the acid test of like whether we understand the theory of them or not, you know, because our theory might predict that this would happen, and then we see whether it does or not. So some of these ideas about, you know, niches changing with habitat alteration, allowing non-native species to get established, sort of makes sense based on our theories. Okay, so let's talk about human land use and its effects on streams. So what are some of the things people do to the landscape that we would expect to affect streams? And I know we've talked about this a little bit already. Mm-hmm. Yeah, and that's actually one thing that we're not going to talk about today. But yeah, so we do straighten channels, and then what we call armoring the channel so that the stream won't be able to move. For sure, for sure. Ag, yeah. What are the ways that we might expect increased agriculture use in a watershed to affect the stream? It's like an echo in here. Yeah. Sedimentation, right, exactly. So we've got ag going on, we've got channelization going on. What else? Yeah. Yep. So we're affecting the water cycle, altering it by having less water going into the ground and more going over land into the streams. Uh-huh. Yeah, absolutely. Absolutely. Lots of stuff. Yeah, man, you think about all the stuff that's on the parking lots going straight into the streams through those storm sewers, right? It's pretty scary. I mean, it scares me. Should go as an anthropogenically altered watershed for Halloween next year. Cool. Any other thoughts? So yeah, so we've got agricultural impacts. We've got urbanization affecting hydrology, pollution, agriculture affecting sediment input, right? Because we don't have those big trees with the roots that hold sediments in place. We've got these small annual crop plants. They're not going to do it. Yeah, so I mean, if we just kind of come up with a list here, y'all pretty much hit the nail on the head. The nails, multiple nails here. It's kind of embarrassing. We're doing a little bit of work on our house, doing a little addition, and the guy that was coming to work there is like, all right, hey, you want to go ahead and nail this piece up? Put 3 nails here, 3 nails here. It was embarrassing. It's embarrassing. My nails hit to nails embedding ratio. It started out at about 4 to 1. Like of every 4 nails that I started, 1 would actually go through. Toward the end of the board, I was about 2 to 1. So sorry, it just brought back bad memories. Then my friend Tim came with his nail gun, and then it was game over. The ratio got much better at that point. But so y'all nailed all these things that are going to happen when we start affecting the watershed. So we're not going to keep our soil. Soil becomes sediment. It goes from the good side to the dark side. It's the foundation of life on the terrestrial ecosystem, the bringer of death in the aquatic realm. So nutrient enrichment, as well from ag, contaminant pollution, all the stuff that gets into our watersheds from, a lot of it has to do with, the EPA regulates pollution, but it's more non-point stuff, right? It's the stuff that runs off primarily. Mentioned hydrologic alteration. Our riparian zone, of course, is going to look a lot different, especially here in the mountains where we like to farm right up to the edge of the stream because we don't have a lot of flat agricultural land around here. So if we can, that's that flat fertile land. We want to use like every inch of it, but that's not good for the streams. It's going to open up our canopy and clear the riparian zone. Another real interesting thing, we haven't talked about this much, is that we used to have a lot more large wood in our streams. Our streams used to be a lot more dynamic, like from a damming perspective. Like so we had a lot more beavers on the landscape, and because we had a lot more big wood in the riparian zone, it would fall in from time to time, and there would be this change. I mean, streams and rivers used to be a lot more dynamic than they are now, even without channelizing them. Trees would fall in and they would be there for hundreds of years typically, right? Well, when you start cutting down trees, moving them off the landscape, you take that wood out of the stream because that wood, just like beavers, creates small ponds above them. That used to be a natural part of our landscape, but it just doesn't work well with development and people living nearby. So we're just going to talk about a few of these today. Talk a little bit specifically about how ag affects streams through nutrient enrichment. We've talked a little bit already about hydrologic alteration and what happens with that. And then sedimentation, which can kind of happen from both of these processes. The fact that we have more water running through our streams can increase erosion in the stream itself as well, right? So not just in the landscape, but in the stream itself. When we have more water hitting that stream than there used to be, there's more erosive power. So the stream, as we call it, gets down cut. The channel gets lower and lower and lower and lower. All right, so thinking about how land use affects our composition of species, I want to say at the outset, it's really interesting because a lot of the research on how land use affects streams has been done in this part of the country. At places like University of Georgia, Virginia Tech. There are folks there that have been since the 80s doing a lot of this kind of research. So in the Southern Appalachian, it is an interesting part of the world too, just because of what's been happening to the landscape. So to begin with, we're in the Mississippi River Basin here, so we have pretty high fish diversity and very high levels of endemism. So we have a lot of fishes here that don't occur other places. Up until recently, the southern U.S. had the fastest rate of urbanization. You know, lots of other parts of the country had just sort of developed already. So y'all may be familiar with this story, right? The forest clearing began largely in the 1880s. It was part of this process where during the Civil War, Army officers came down and saw just the incredible richness of the timber forests and came back down and started some of these big operations, clear cutting it. There's almost no old growth forest left, just a few fragments here and there, right? Places like Joyce Kilmer, I know this little patch, it's Coleman Boundary, places like that, but not much left. But since then, we've been increasing our forested land, right? You look at places like Bent Creek, right? And you walk there and it kind of, I mean, it feels like a natural forest, you know? Which to me is one of the crazy lessons of ecology, which is just how fast ecosystems can recover if you just stop messing with them, you know? But that's not an old growth forest, right? 99% of, maybe not 99, 95% of the Forest Service land in Western North Carolina, it's secondary growth. It's not old growth. So this is all secondary reforestation that's happened. I'll tell you a little story. David Starr Jordan was an ichthyologist at Stanford University around the turn of the 20th century. And he traveled to the east to make some fish collections and see what species lived out here. Well, around 1900, there was so much massive erosion here because so many trees have been clear cut. He was unable to even capture any fish in the French Broad River. It was so turbid. And you might have heard the saying, they used to say that the French Broad was too thick to drink, but too thin to plow. That's how much sediment was in it. It was crazy because of all this massive deforestation in the late 19th century. It was crazy. So it's easy to look at the environment now and be like, oh man, it's awful and it's getting worse. Well, no, in a lot of places, we're doing better now than we used to. This is back in the day, pre-Clean Water Act and all that. So since that time of the early 20th century, we were in bad shape in this part of the country. It's been reforesting essentially. So we have succession, and also there's been this abandonment of agricultural fields, but then there's been some residential development. So suffice to say, this is kind of a dynamic part of the world from a land cover perspective, land use perspective. So it's interesting to study. So we looked at 36 streams, some of which are in the French Broad drainage, some of which are over in the Little T. And of course, both of these ultimately flowing into the Tennessee. And did some GIS work, those of y'all that have taken the GIS course. So went through and calculated things like channel gradient, watershed area, elevation, and then land cover as well. Much of the land cover was forested, how much was forest cover change. Then what he did was he broke fish out into two different categories. He broke them into endemic species. What does endemic mean? Have we defined that term? What does it mean if a species is endemic to an area? Yeah, native to that particular area, and really only that area, right? So not very widespread. Yeah, so native to only that area. So we do have a fair amount of endemic species, and y'all have seen some of them. So the Tennessee shiner, the mirror shiner, war paint shiner, saffron shiner. Those are all endemic. You don't really find those anywhere else. Let's see. I wonder if you saw any of these darters. Swannanoa darter is one of them. Fantail darter, exactly. I don't know if did we see any redline darters? Maybe we didn't. Maybe it was it with, where did I see redline darter? Oh yeah, maybe with your research. Maybe MC was into. I forget. Were you when we saw that darter that was really bright red and white and stuff? Maybe not. Anyway, they're here. Trust me. Okay, so anyway, this list of endemic species, but there are also species here that you find all across the country. These more cosmopolitan species. They dress very chic. They wear cool sunglasses. They see them hanging around in coffee shops, drinking things. And we've seen some of these too: central stone roller, river chub, creek chub. What else? Black-nosed dace, northern hogsucker. Right? These are things you find all over. Okay, so he broke species into these two categories, and then he looked at, for a given site, was it dominated by endemics or cosmopolitan? And so we did this thing where he subtracted the relative abundance of cosmopolitan species from the relative abundance of endemic species. And so, of course, as this number is higher, then you've got more endemic species, right? So how would you expect land use to affect this number, just like before you even start the study? Yeah, that's the principle, right? Maybe I don't even need to show you guys this example, right? But it's still good, right? Because you hear people say things and you're like, well, show me the data. Or at least as a scientist, you should be. So I'll show you some data. Yeah, so you might expect, right, exactly, that areas that have been more degraded might have, relatively speaking, more cosmopolitan species, which would make this value lower, right? All right, so lots of numbers here, but I just want to kind of give you the take-home message here. So toward the top here are the predictive models that worked best to predict this value. And so these land use variables were real strong predictors of this index. And so as this number gets higher, it's more endemic species. Okay, so if we look at catchment forest cover, it had a positive effect on this, right? Which means that, yeah, watersheds that had more forest cover had, relatively speaking, more endemic species. And then these two variables had negative impacts, right? So intensity of urbanization, that was essentially how much of the watershed was urban. Increasing urbanization led to, relatively speaking, more cosmopolitan ones, as one might expect. Similarly, forest cover change. So watersheds that had experienced more forest cover loss had, relatively speaking, proportionally more cosmopolitan species. Okay, so kind of what we might expect, right? This idea that, like, if you're cosmopolitan, you can live all over. If you're endemic, change is not a good thing, right? If you live here and only here, that means you're probably pretty specialized. So change to the watershed probably not going to be good for you. All right, now I'm going to tell you, I read this paper when I was teaching in Austin College in Texas, and I'm like, first of all, I'm like, French Broad River, what a strange name for a river. But then I also thought, wow, this paper is crazy. This is one of those other papers that, like, blew my mind, kind of changes my concept of how ecosystems work. There's a ghost involved here. That's all I'm going to say. So John Harding, who's now a professor out in Australia, but was doing graduate study at Virginia Tech at the time, looked at fishes and invertebrates in 24 tributary watersheds in a similar area, French Broad and Little Tennessee River. I tell you, like, we have studied the heck out of this part of the country to learn about land cover effects on streams. But he divided these up so that 6 were agricultural and 6 were forested. But then he did what I thought was a really interesting thing. He not only looked at what the land use was like when he sampled in the 90s, he went back to historical records and he looked at what the land use was like in those watersheds in the 50s. All right. And as you can clearly see from this table, what he concluded, sorry, that wasn't funny. Don't do that when you're giving a seminar. Anyway, so he calculated all these things, including an index of biotic integrity. This is for North Carolina. We're special. We got our own biotic index. We looked at density of invertebrates, EPT. You're familiar with that, percent EPT. And these other index, it's like the measure of diversity, how many taxonomic richness, just how many invertebrates. Then looked at number of fish species, again, an index of fish diversity, abundance, and then looked at the total number of species of fish and inverts. Yes, he identified invertebrates as species. Do not run screaming from the room. He did it. And then, I don't know, did all this other stuff and like looked at a bunch of things. So we had land use data from the 50s, from the 90s. I don't know. He looked at it at the whole watershed level, like what was land use like in the whole watershed. We also did some funky things. He looked at, what's land use like just in the 1 kilometer upstream of the site. What's it like just in the riparian zone, just upstream from the site? And what was really interesting here was that most of the variables that were strongly significant were variables of land use from the 1950s. Hence the ghost. What does that mean? That I'm standing here in this stream today. I'm taking my little Cerber sampler. I'm looking at, the diversity and abundance of invertebrates today. But what's really predicting what's there today is what the land use was like 50 years ago. Like, why? That's kind of crazy, right? Why might that be? Any thoughts?
Maybe it's like one of these things like exponential. So like if there's a factor that negatively impacts the land use or whatever, that factor will like exponentially. This is better, that's not, and then it expands and it gets worse over time.
Oh yeah, so maybe the effects are just kind of carrying on and being amplified. Yeah. So there's something. Yeah, no, I knew what you meant, like kind of getting stronger over time. Yeah, so right. So whatever's happened in the last 50 years, it hasn't undone whatever 50 years ago did, right? Kind of crazy. My mind kind of was blown when I read this. Anyway. And then they did this multivariate analysis of the community, the invertebrates here. And the only point I want to make here was that when they looked at the community composition, the dark shapes are in forested, okay? And so all you need to know about multivariate analysis is it groups sites that have similar species composition. It looks species by species and it calculates like how similar they are. And so these were forested sites in the French Broad and the Tennessee. These were ag sites in the French Broad and the Tennessee. These outliers are sites that are forested in the French Broad, but their species composition came out with the agricultural sites. Again, because what was really determining the species that were there is not what the land use was like. No, it's what was there 50 years ago. So sometimes we call these legacy effects. Harding called it the ghost of land use past. The point is, these historical effects have long-lasting impacts, right? When you think of what happens. Because if the landscape is degraded today and we lose a species, if we make the landscape look better this year, is that species going to come back? I didn't give you enough information to answer that. If we've eliminated it from the watershed and we make the habitat better, and it's an aquatic species, is it going to show up that next year? No, it's not, right? It's not just going to emerge from the rocks again when the habitat's good. Like once it's gone, it's gone. It takes a while to recover, right? That time around 1900, there was a fish called the spot fin chub that was collected at Swannanoa River near Biltmore, right there near the where the railway crossing is. That fish is now on the endangered species list. Hasn't been seen in Swannanoa for like 80 years. Like it was just gone. Like it couldn't handle living in like a river of chocolate milk, so like it went away and hasn't found its way back. So the point is, you know, these sort of long-term legacy effects take a long time to come back. So to understand what you're looking at when you're looking at a river stream, you have to understand the history, right? You really have to understand the history of the landscape. There's interesting implications there for restoration about how much time we would expect restoration to take, right? To try and get these sites looking nice again. Okay, yeah. So anyway, this kind of puts a bow on it. Yeah, in particular, this 30-meter buffer zone was the best predictor, but there were lots of models that used the 1950s data. Yeah, so yeah, it's just interesting. It's interesting what stories are there that you don't necessarily see. You kind of have to go under the surface to get the story. Sorry, I couldn't help myself. All right, just one other thing to share. And I'm hitting you with a lot of data, but anywho, these folks, again, looking at the same basins, we're looking at silt. And what they found was that as I didn't introduce this very well. This was essentially the length of the intact riparian zone. So, you know, imagine that I'm standing here in the river, which is hopefully not all that hard to imagine. And on my left and my right, there's an intact riparian zone, but then like 10 meters up, it's trash, right? Like, what does that mean? As opposed to like 100 meters, a kilometer. So looking at how much intact riparian zone is good, you need. Anyway, what they found essentially was that as the length of the intact riparian zone got shorter and shorter, am I saying this right? Yeah. Well, I think my axis may be weird here. I apologize. The take home here was that when there was less forest, these fish that started to dominate that were silt. Men in Black, forget I said that. Okay. When there's less forest, you guys can probably read this. I confuse things so much. I muddy the waters as if there's been silt washed into them. When there's less forest, you get less of these species that are silt intolerant, right? So things like darters, sculpins, benthic minnows, things that feed on invertebrates on the bottom, right? That can't feed in the mud because there's not stuff that can live there. On the other hand, when there's less forest, there's an increase in sunfish and water column minnows and introduced species. I thought this was interesting just because you remember our results on like numbers of fish for Sweeten Creek versus Beatree. And we have more species at Sweeten, but those included like sunfishes and things, right? So when you think about it, like those silt tolerant species were there, which meant more species, which you could say is awesome. But those species that were there were those that were tolerant of silt. And there just weren't, I mean, we had one pool there at Beatree, but we didn't have like any kind of silt bottom pools that, you know, sunfish could hang out in. So you have this sort of shift in species composition. Anywho, the other interesting thing they noticed here was that as the yeah, I think I introduced this improperly. So this is the length. This is the length of the disturbed portion of the riparian zone. And so they looked at some species of darters and some sculpins. And anyway, what do you think they concluded about this? So this, I apologize. This is the length of the disturbed patch of the riparian zone. I say, why am I confusing myself? Yeah, yeah, because when there's none that's disturbed, you have high density of these benthic species. So this is the length that's disturbed. I apologize for my confusingness. What do you think they concluded from looking at this graph and this graph? And note the dotted line. Yeah, exactly. There's some threshold of maximum patch length here that they can deal with, right? So you can disturb up to about 3 kilometers of the riparian zone and still expect to find some of these sculpin, but then when it's above 3 kilometers, they're just not there, right? That's just too much of a disturbance. And with darters, it was a little lower of a threshold. So basically, you know, it says something about how tolerant they are to disturbance in the watershed. Does that make sense? So anyway, so sometimes we call these like thresholds. But so the point is there's not a linear relationship. Like, so if you're a resource manager and someone is, you know, proposing to develop in the riparian zone, you might approach that question differently if there's a lot of the riparian zone that's already messed with, whereas if there's a little, right? So if you're way out here, it's probably not going to have much more of an impact. Whereas if you're here, it really could. So anyway, so this idea of a threshold patch length, this kind of means that like up to a certain point, you can degrade the habitat. It's not going to negatively impact them. But then once you get beyond that point, it doesn't matter how much more you degrade it, you're not going to lose them more because they're already gone. That kind of relates to what we were thinking about with dam effects on the Karnali River in Nepal, because that's a river that didn't have any dams on it at all. So the first dam is going to mess with migratory species and stuff. Whereas like other rivers that have like 3, 4, 5 dams on them already, like the species already can't migrate, right? So there's less of a cost. Okay. Is that correct? Kind of, sort of. What's that? It's, well, I think it actually is, yeah, it actually is, well, yes, it's off by an hour. But yeah, I know. And the worst is like when you think that it's not reset and then someone resets it, and you're like, oh my God. Because the clock in our bedroom, we hadn't set back for a long time. Then I set it back, and my wife was like, oh my gosh, what happened? I'm like, oh, I set it. Right. I don't know. You got any questions or thoughts on land use effects on streams? Anything else you want to know, or anything that doesn't make sense about it? Yeah. Olivia, that's really the point that I'm coming to. And it partly has to do with what we learned about trying to restore degraded streams. Like you can't, you know, like you've got an urban stream, it's so hard to restore it. So I think, you know, there are people that would argue with that and would say that, you know, any kind of degradation of the environment is bad. And I'm not arguing against that, but yeah, I would say that if, you know, what we're learning about impacts on nature of all kinds is that you really want to protect the pristine areas. Like you really, really want to protect those. But, you know, like Glenn's Creek here, you know, I don't know that we can do anything to it. Well, I shouldn't say that. But it'd be really hard to do something to it that would cause the creek chubs to go away and the black-nosed dace to go away. But Bee Tree Creek, you know, Bent Creek, there's a lot of species there that a little bit of disturbance, we could lose them. So I do think that's one of the main points from a resource manager perspective is if you can target certain watersheds to protect And then of other watersheds that are developed to a greater extent. That makes a lot of sense. Yeah. And again, I don't know that everyone shares that perspective, but I think a lot of folks do. I know with what we were thinking about in Nepal, where you do have like still pristine whole watersheds, everybody's like, look, this river that has 5 dams in it already, like max it out if you need hydroelectricity, like max that out, because the migratory species are already not going to be able to hang there. But if you build that dam in a river with big migratory species that are able to do their thing, then you've had a huge impact on the way the ecosystem works, So
land use affects streams, like to the year in, and then like for example, we talked about earlier how like Bank Creek 50 years ago wasn't pristine.
yeah.
Biggest difference is just like water, land, and then so the stream doesn't come back as easily as the land does.
I think you're right. The one thing about all this Forest Service land is that we didn't develop it. We cut the heck out of the trees, and then we left it alone for 50 years, and it kind of came back. Now, if we had cut the heck out of the trees, built a big box store with a parking lot and all that kind of thing, then you've knocked down the ecosystem's ability to recover. And it did, man. I mean, it did. Like, it took 50 years, right? I mean, it really did. Like, you look at pictures of like Mills River and stuff back in the day, like it was a mess. Like it was smashed. So it did take 50 years. But because it was 50 years of letting nature do its thing, not 50 years of us pounding on it, it came back. And yeah, I'll tell you though. Yeah. So what I'd say, I'll tell you, like Bent Creek, the first time that I put a mask on and got actually into the creek and started looking around in it, like it surprised the heck out of me how much sediment was in that stream. Like Bent Creek is over 90% forested, right? In most 90% forested watersheds, like you're not finding a pool full of sediment, like you're finding gravel, you're finding all that other stuff. And this actually, we were doing a study on hellbenders in there because one of my research students, they'd seen one, but there wasn't a historical record. So we literally did the whole, but all Bent Creek from when it enters the French Broad up to the dam on Lake Powhatan, like we literally walked up looking for hellbenders with masks and snorkels and stuff. And that creek, you can tell it's not pristine. But, but to be honest, like hellbenders, like we found like 3 in the whole stream. I guarantee you there were more than 3 hellbenders in there, like in the 1800s, like before all that clear cutting happened. So Bent Creek has, and that's a whole other interesting topic. Yeah, like Bent Creek has recovered up to a point where we'd say it's pretty good. And the other thing is that inverts are going to recover quicker, right? Because the adults fly. So wherever there's a good habitat patch, they're going to find it. They're going to oviposit. They're going to live there, right? Whereas, things like fish, of course, they have to follow like the linear like stream to get, like it's hard for them to get there. So when we look at the invertebrates at Bent Creek, like it looks beautiful. Things like hellbenders, which are long-lived, intolerant, and take a long time to get places, like they're still not where they should be, really. But yeah, certainly comparing Bent Creek to Glens Creek, though, if you're gonna, I don't know, build a Trader Joe's with a big parking lot, do it in the Glen Creek watershed as opposed to the Bent Creek watershed. But yeah, I mean, yes. Non-native species. Yeah, I don't know. How about non-native species? Anyone know what this is? It is, yeah, Japanese knotweed. Yeah, and we saw some of it there at the Sweeten Creek site, right? Didn't we along the bank, I think? Yeah, there's been some studies looking at how it affects how leaf litter from Japanese knotweed breaks down differently from leaf litter of native plants, and it's not all that different really. So it probably doesn't matter that much. But yeah, I don't know. It's an interesting thing. It comes into the disturbed part of the riparian zone and takes over. So in that case, it's good because it holds the riparian zone together, but then it doesn't let native species get established. So I don't know, but so yeah, so things like Japanese knotweed, things like brown trout, we've got lots of non-native species. So I know some of y'all are familiar with this already, but I just want to kind of break down the vocab because you hear a lot of words talked about species that aren't from around here. Anybody see the movie Rango? Yes, you're a stranger. Strangers don't last long around here. The problem with non-native species is sometimes they do last long, and then you got problems. So, what are the differences in these terms? Non-native, exotic, non-indigenous, alien. Sounds scary. Noxious, invasive. Any of those synonyms? Yeah, they are. Yep. So like these four basically mean the same thing. Like just that they're in an area that they don't naturally occur. That's all that means. What about the last two, noxious and invasive? What's up with those terms? Any thoughts? Yeah, noxious. So there's a noxious plants list that's maintained by the department by USDA, and it's like a legal designation. Yeah. So noxious means that it's physically destructive or harmful to living organisms. And then just like you were saying, Dasi, yeah, like invasive just means that they're having some adverse impact. So noxious native plants. Any plant people? Anybody taking D's class? Does she talk about that at all? Are there native? Like, is there such thing as a native noxious plant? Right. Yeah. Yeah. So that's right. So So right. Sure. There are examples of that for sure. Yeah. So right. The problem is when they're like non-native noxious. Yeah. Yeah. So Didymo is interesting because it's well, I don't want to spoil it, but can a native species? We'll just leave that question hanging there. I don't know. You can bring that up. But that's right. I mean, because because that's the other thing due to climate change and habitat alteration, we do have species that are becoming more abundant in their native range where they weren't before. And so species could start to have these impacts that didn't before. But yeah, really, from an ecological perspective, like these are the categories that we're most worried about. Yeah, and it's really interesting to think because we always hear about successful invasive species. There have been some papers that show that the vast number of invasions are not successful, but the ones that are problematic. Okay, so how do they get to new habitats and streams? So we're talking about stream species here. We talked about some of this the other day. So being stocked for sport fishing, this fish called the peacock bass, which is neither a peacock nor a bass. It's a cichlid from South America that is now found in Florida. I think pretty much to qualify as a non-native invasive species, you have to occur in Florida. If you don't occur in Florida, just forget about it. You're some kind of wimp. You can't. It's got to prove yourself in Florida. Then we'll talk about you being non-native invasive. The aquaculture industry as well has brought lots of species over. The grass carp was brought over accidentally, like a lot of other species. Actually, no, I apologize. It was brought over on purpose to be used in catfish farms to eat grass. because it's a grass carp. But of course, you guys have seen Jurassic Park. You know what happens. Nature finds a way. Flooding comes along. The grass carp all of a sudden aren't just in the ponds, they're in the Mississippi River. So aquaculture has brought a lot of species intentionally for use by humans, and then they get out and they can cause problems. We've also brought several species over for biological control, including some varieties of mosquito fish in the genus Gambusia. These are in Lake Powhatan at Bent Creek. They're in there. They're also in Sandy Bottoms, the little wetland over there. So we brought these around, and they're effective, man. I remember watching a presentation after Katrina, when there was all this massive flooding. A lot of people had swimming pools, which then got filled with dirty, nasty water. Fish. You're kind of there. But these swimming pools that had fish in them had a lot less mosquitoes. Swimming pools that didn't have fish in them, mosquitoes were awful in New Orleans following Katrina. So what they did was they went in and the state put these Gambusia mosquito fish, because people didn't come back to their homes for a long time, right? So there were just abandoned homes of swimming pools full of mosquitoes, and so they put these mosquito fish in there, and they did well. I had a weird experience. I went to a meeting in New Orleans before Katrina and then after, and I always remember there was a picnic. This is the American Society of Ichthyologists and Herpetologists. It's a cool group, and they took us by bus to the Audubon Zoo for this picnic, and it was at night, driving by all these neighborhoods just like with no lights on, because like nobody was living there. It's really weird. But then we also have a lot of species that are hitchhikers that get there by accident. So the zebra mussel is an example, brought from the Baltic Sea from Northern Europe, in the ballast water of transatlantic ships. They'll take on water at the port that they're leaving to balance out their load, so they don't get out of balance on the ocean. But then what they do when they get to their port of destination is they release that ballast water because it's no longer needed. And so zebra mussels have larvae that float in the water, planktonic larvae. And so their larvae got sucked into these kinds of ships, released in the Great Lakes, got established. This is a shopping cart. This is in the water. They don't colonize shopping carts on land. You don't have to worry at Aldi that like the shopping cart you pay $0.25 for is going to be covered in zebra mussels. That doesn't happen. But if it was in a lake, and I don't know why the shopping cart was in the lake, but it was, and now it's covered with zebra mussels. Or someone bought a lot of zebra mussels. No, they didn't do that. Our topic of the day, Didymo, sometimes affectionately referred to as rock snot, also hitchhiking its way around. Yeah, because these are tiny, and they just need a drop of water. You need to get stuck on your boots or your boat, that kind of thing. So lots of aquatic species get moved around by accident. And one of the things that's happened is that we have consistently removed barriers between aquatic habitats. So for instance, this is Lake Ontario in the Great Lakes, Lake Erie in the Great Lakes. The Welland Canal was built. Why? Well, because it's hard to sail up Niagara Falls, which the Niagara River is over here. Is that? Yes. Sorry, it is. Okay. It is. I'm like, what? Do you guys ever do this on Zoom? Just do this to make people think that your connection froze up, but you didn't really? It's kind of fun. Especially when like someone's going to ask you a question, you know the answer to. Anyway, anybody know a species that moved through the Welland Canal and colonized the rest of the Great Lakes and its streams? You guys know that feeling when you don't know something, you're about to know something, and then you're gonna no, they're scary. You're gonna wish you never saw them. Sea lampreys. Ugh, gosh, something from a nightmare. We have nice, small, cute little lampreys around here, and our lampreys here also have larvae that live in streams. These are sea lampreys. They attach themselves to fish and then suck out their juices, for lack of a better term, or maybe that is a pretty good term. and they're bad. So they migrate through there. I think we can talk about this and we'll wrap things up. I love, scientific papers that incorporate like fun kid songs in their titles. It's a small world after all. So connectivity and homogenization of freshwater faunas. So the idea is that we could think of the world as a series of filters. Kind of like when I was making the tea for our field trip last time. And I didn't want all the stuff in the tea, so I poured it through a filter that filtered it out. Well, if we think that we are in a stream and we want to know what species are there, well, we can start with what's called the global species pool, right? So all the species on Earth. But they're not all going to be there. Some of them are going to be on the continent. And so if we think of like a continental filter, that is going to determine what species we find on the continent. Okay, so let's just say that I'm in Glens Creek here. I'm in Glens Creek. I know that there's thousands and thousands of fish species in the planet, but only some are going to be in North America. Well, which are in the French Broad River? Well, there's going to be divides between our watersheds that are going to keep species from moving among watersheds. But even of all the species in the French Broad River, they're not all in Glens Creek. And so this is going to be things like barriers to dispersal. And so humans have found ways to bypass all of these filters, right? So the fact that you can find zebra mussels now in the Great Lakes means that we've come around these filters. So for instance, the things that we mentioned, aquaculture, sport fishing, ballast water transport, those transport species to continents that wouldn't normally be there. Okay, but what about species that are in the continent that wouldn't normally be in the river basin? How do we move those around? Well, these are things like the shipping canals that I mentioned, so building canals between basins, transporting water from one basin to another for human purposes also moves species around. Bait bucket release, I think I may have shared with y'all, there's a fish called the rosy-side dace we find in Swannanoa River, which is not native to there. It's native across the river basin in the Catawba and Yadkin PD drainage. One of my students did a little bit of genetic work on it, and turns out it's identical to the species across the divide. Probably a bait bucket release. You know what I mean by that? You go fishing, you got some minnows to use for bait, and you're fishing, and at the end of the day, you haven't caught anything, but you got 3 minnows left. So what do? Dump them into the creek, right? So introducing species. And then, if we, again, these finer scales. So I think it's good to think conceptually of all these different filters and how humans bypass them.